In this session, we are talking about acids, bases, and salts for Class 7 Science Chapter 5. Acids, bases, and salts, Class 7, Chapter 5, NCERT pattern. What are acids? Now, we have studied there are various substances found in the nature. Other than the minerals and metals, there are organic substances, there are inorganic substances. Now, these substances we have studied are also classified into elements, compounds, and mixtures. We also know elements means the smallest or basest form of any material, while atoms are the indivisible smallest particle of an element. Compound means combination of one or more elements. Mixture means combination of one or more elements, but not necessarily in a definite proportion. Now, in our daily life, we get food, clothing, and shelter. Now, each of this food, clothing, and shelter is made by various elements and compounds, minerals, and materials. Now, there are some things for our needs, there are some things for our wants. Now, what happened is mankind started exploring nature, mankind started exploiting the environment, and then slowly we were able to discover the existence of various substances in the lithosphere, in the crust of the earth, in our land, and some in the ocean floor also. Now, there are various materials that touch our daily life. These are made up of elements or compounds or mixtures. Now, what is special about this is each of these substances are having probably a different taste, they are having a different texture, they are having different properties, they are having a physical characteristics are different, the chemical properties are different. Physical characteristics, chemical properties, both are different. Now, physical characteristics we also call it as a texture or whatever. Now they react differently when they come in contact with other substances. If you add one substance called carbon and another substance called chlorine, the way they react with each other is not necessarily same as when you add oxygen to carbon. So they have different reaction with the different substances. What are the different tastes of different substances? For example, the taste of lemon is so, tamarind is different, salt is salty, sugar is sugary, then you have a vinegar, then you have a amla or a mango. The ripe mango is different from raw mango because of the chemical reaction by which the vegetable becomes a fruit. Grapes have a different taste, berries have a different taste. So these tastes are different because of their constituents. They consist of certain materials which can be classified as elements, compounds, and mixtures. Certain materials which can be classified as acids or bases or salts. Now, what's the nature of a material? They can be classified based on whether they are sour or not, salty or not, bitter or not, sweet or not, or they have no taste or not. Then they have a order, different smells they have. Then they have pungent smell, etc. We say, right? And then they have the way they taste, the order, then whether they are powdery, whether they are soft powder, whether they are coarse grains, whether they are um, crystalline, whether they are metallic, based on that. Likewise, different substances have different textures. Now, coming back to the taste, sour or salty or bitter or sweet, can we taste them and find out? Some of the materials we can taste them. Not all materials are good for human health. So, you cannot put everything on your tongue or cannot take everything in your mouth. Some of them you can. Now, sugar, you can see what is a taste. Salt, you can see what is a taste. Lemon, you can see what is a taste. Mango, you can see what is a taste. But you cannot do this for everything. So, what happens is sometimes your taste may not be the best way to observe the nature of a substance. So we need some indicator to tell us what substance is it. Is it tasting acidic? Is it tasting basic? Is it sour? Is it salty? So what are those indicators? There are some indicators that occur in the nature naturally, and some are man-made. Indicators are those that change their color when they are added to a solution of another element or compound. Indicators are those that change their color because of the reaction when they are added to or when drops of solutions of some other element or compound are added to it. What are the sample indicators? Litmus paper is one indicator, turmeric is one other indicator, China rose is one other indicator. When we say litmus paper, actually we are creating a paper that has contents of the litmus, that has litmus pasted on it or dipped on it or etc. That is the litmus paper. Dipped on what? Dipped on something that we get from lichens. We will see that in detail. Okay. Now, This lesson is about acids, bases, and salts. Or what are acids? Acids are something that are acidic. Curd, lemon, etc. are acidic. They have a sour taste. The word acid comes from ACER, acere, and then they contains hydrogen ion H plus. We know every element is represented by a formula H. Every element has the most further cannot be subdivided type of smallest particle called atom. Atom consists of electrons, protons, and neutrons. Sometimes an atom gains or loses an electron. When it gains an electron, it gets a negative charge. When it loses an electron, it gets a positive charge. When an electron is lost or gained, they are called ions. And then when it is a positive, it is called a cation. When it is negative, it is called anion. All those things we know basics about the elements and compounds and the way their formulas or their indication are there. So some are isotopes, some are ions, and only when they are an ion they will bond together. That is called a chemical bond. The strength of the chemical bond will depend upon how positively or negatively they are charged. They should be equally charged. If there are two plus on one side, there has to be two minus on the other side. Only then they will form a bond. This is the way. So hydrogen ion, if it is there, it is called an acid. Bases. Bases are example baking soda. Baking soda is an example of base. It does have a basic taste or a basic behavior. It is soapy or bitter in taste. It is not sour like an acid, but soapy. And then it contains hydroxyl ion. What is hydroxyl ion? OH. Now for a base, you will have a negative OH minus. Hydroxyl is OH minus, while hydrogen is H plus. Acidic will have a positive ion, bases will have a negative ion. Acids will have a hydrogen ion, bases will have a OH ion, hydroxyl ion. Now, some of these materials are corrosive. Corrosive means what? Acids are corrosive because they react with the metal. And when it comes in contact with the human skin, it causes harm because it is irritating to the skin. Now, some materials are neither acidic nor basic. Some materials are neither acidic nor basic. Now, what are some examples of acids and bases? Vinegar is an acetic acid. Vinegar contains acetic acid, so it is acidic in nature. Ants, when they sting, they what they do is they put some formic acid on our skin. When the ants sting us, they put some formic acid on our skin. So because of the formic acid, because of the acidic reaction, our skin undergoes an irritation. So what do we do? When we add some basic material to that, the basic material reacts with the formic acid and neutralizes, and the pain of the ant sting goes away. Oranges. The orange fruit or the lemon or any other citrus contains something called citric acid. So it is acidic in nature. Curd. Curd is milk. When it becomes a buttermilk and then turns into curd, the when it is in milk, it has lactic acid. That milk becomes stronger when it becomes buttermilk and curd. So that lactic acid becomes or gives acidic nature to the curd. Now, amla, gooseberry, and all will have an ascorbic acid. Ascorbic acid is something that gives amla and gooseberry their acidic nature. Ascorbic acid is also there in vitamin C. That is why when you have a cold, when you try to take vitamin C tablets, it has a taste similar to the gooseberry taste. Now, tamarind has a tartaric acid. Tamarind has a tartaric acid. Likewise, raw mango also, they have similar sour taste because of the tartaric acid. Now, these acids are naturally occurring in plants and animals. The plants and animals, the milk or the ant or a vinegar or orange are all part of the naturally occurring acids. Now, lime water. Lime is different from lemon. Lime is calcium hydroxide, what you use for whitewashing. That is the limestone lime. That when you mix with water, you get something called calcium hydroxide. Why? Lime is calcium. This calcium hydroxide, because it is hydroxide, hydroxide means OH. OH minus, if it is having a basic character, not an acidic character. Likewise, soap. What is soap? Soap is sodium hydroxide. So when it has an hydroxyl ion, OH, hydroxide is there, it will have a basic character, not an acidic character. Now, to see more details of acids and bases differences, acids are sour tasting, bases are bitter tasting. Acids are corrosive, bases are soapy. Acids are strongly reactive with the metals. Now, acids are mostly soluble in water and become diluted acids. Bases mostly do not dissolve in water, and if they dissolve, then they are called alkali. So, acids, bases, alkali, and then we have the salts. What are the indicators? We have seen litmus, China rose, etc. are the indicators which helps us to understand whether something is acidic or basic in nature, right? Now, one is litmus. Litmus is a natural dye extracted from lichens. Litmus is a natural dye extracted from lichens. It has a more purple color. Litmus basically has a more purple color. It turns red when added to acidic solution. Litmus turns red when added to acidic solution. This you have to always remember. Litmus turns red when added to acidic solution. Litmus turns blue when added to basic solution. Litmus turns red when added to acidic solution, turns blue when added to basic solution. Now, litmus is available in the form of strips of paper. How? On the paper, drops of litmus is added, so it becomes a litmus paper. Or, litmus is available in the form of solution, so we take one or two drops and add it to an acid or a base. Now, red-blue litmus paper, that is called. Why? Because it turns red or blue. Turns red when added to acidic, turns blue when added to basic solution. Bases change the color of the litmus paper to blue. Acids change the color of the litmus paper to red. Another litmus is turmeric. Turmeric is naturally appearing rhizome. Now, this turmeric, we make a paste of the turmeric. We have a haldi or a turmeric powder at home normally everywhere in India. We use it for cooking because it is also an antibiotic. Now, when after making a paste of turmeric, dip a piece of paper on this paste to make that paper turmeric paper. What type of paper? Blotting paper or a filter paper we use so that the turmeric sticks to the paper properly. Now these strips are dried so that turmeric remains dried on the paper. Dip this on a soap water. What is a soap water? Soap is sodium hydroxide, so it is base. Or add a drop of soap water to this turmeric strip paper. What will happen? Did it turn red or did it turn blue or what color did it turn? Soap is basic and it turns red with a turmeric indicator. Soap is basic and turns red with a turmeric indicator. So here also we saw the basic turns blue. Here the basic turns 10. Hydrochloric acid is yellow to blue. Hydrochloric acid turns turmeric yellow to blue. The acid turns to blue. Here acid turns to red. Here base turns to blue. Here base turns to red. Sodium hydroxide is a base. It turns yellow to red. Sodium hydroxide is a base. It turns yellow to red. So turmeric reaction is almost opposite of the litmus reaction. This is red to red when it is acidic. This is turns to red when it is basic. This is indicator litmus, indicator turmeric. Now we have a third indicator which is China rose, Gudal. Now China rose, what we have to do is we have to mix the petals of China rose on warm water for some time. Why? The characteristics of the petal, the chemical content of the petal should come into that water. And then this water is called the indicator water, indicator solution. It turns basic solutions to green. It turns basic to green. Here basic to blue. Here basic to red. Here basic to green. Right? So different reactions. This turns basic to green and acidic solutions to pink. Here acidic is red. Here acidic is blue. Here acidic is pink. So this is how the change of the color absence. Acidic is pink, acidic is blue in turmeric and acidic is red in litmus. Different types of indicators. There is one more indicator which we will see later. Acid rains. What are acid rains? Now what happens is due to factories, due to use of vehicles, lot of pollution happens to the air. The polluted air contains carbonic acid, sulfuric acid, nitric acid, etc. Different types of acids are there in the polluted air. How? The polluted solid particles along with the water vapor in the atmosphere or cloud becomes carbonic acid, sulfuric acid and all. This carbonic acid or sulfuric acid comes along with the rain to the land, to the lithosphere from the atmosphere. This causes damages to old buildings, for example, Red Fort or Taj Mahal type of old buildings. It causes damages to plants. It spoils the water bodies. So all these damages happen because of the carbonic acid that comes in the rain. Carbonic acid comes because carbon dioxide, sulfur dioxide, nitrogen are there in the air. These are in the air because of the pollution. So the rain containing excess of acidic characteristics is called acid rain. Rain containing excess of acidic characteristics is called acid rain. The rain contains excess of acidic characteristics because of the carbon dioxide and sulfur added to the atmosphere due to pollution, which gets converted to carbonic or sulfuric or nitric acid, which can cause damage to the water bodies or monuments, etc. This is acidic rain. The other indicator that we talked about is phenolphthalein. Now, what is it? When you add 2 3 drops to a dilute hydrochloric acid, what is hydrochloric acid? Acidic, and when you shake, it becomes colorless, right? Then add a few drops of sodium hydroxide, which is a base, then stir slowly, pink color appears. When you add hydrochloric acid, it becomes colorless. When you add sodium hydroxide, it becomes pink. When you further add hydrochloric acid, it becomes colorless. When you further add sodium hydroxide, it becomes pink. It means what? Colorless, pink, it keeps on changing. This is a specialty of this indicator. Okay. Now looking at the reaction between acid and base. Now reaction between acid and base is a neutralization reaction. Why neutralization reaction? It won't be acid anymore or it won't be base anymore. That is called neutralization. Salt and water are mostly produced. Salt means, this does not mean the salt that we eat along with our food. The byproduct or result of the neutralization reaction between an acid and base is the salt, and then water is also released. Sometimes heat is also released. Now this salt may be acidic, basic or neutral. The salt produced by the reaction between acid and base in a neutralization reaction can be acidic or basic. Heat or energy is released. When an acid solution and a base solution are mixed in suitable amounts, both the acidic nature of the acid and the basic nature of the base are destroyed. Acidic nature and basic nature are destroyed when they are mixed in suitable amounts. They produce salt and water, and the salt may be acidic or basic, and heat is released. What are the uses of neutralization? Now, calamine solution contains a zinc carbonate. It's a very weak base. If a base is strong, it may cause damage to our skins. If the weak is base, it will cause little damage. Why we use this calamine solution? When there is an ant bite, which is formic acid, we add lactocalamine solution. Lactocalamine we use for facials also. This lactocalamine neutralizes the formic acid. What happens? Zinc carbonate and formic acid, sodium hydrogen carbonate, react, and then it neutralizes, and so you don't have the pain of ant bite. Some people will have a gas trouble when they have certain types of food because the stomach produces certain acids and certain bases for the digestive purposes. When the acidity of the stomach is more, or the acid produced is not used up for digesting the food, and then what happens is the acidity of the stomach goes up. So then they feel the reaction in the stomach is not giving them any comfort, the discomfort they feel. So people take antacid. You would have seen people taking Pudinhara types of antacid also. So antacid is what? Antacid is called milk of magnesia. This milk of magnesia neutralizes the excessive acid in the stomach and brings comfort. So antacid reaction, neutralization with excessive acid in the stomach. Calamine solution containing zinc carbonate reacting with the formic acid, that is sodium hydrogen carbonate, is another use of neutralization in our daily life. Factory waste. Factory waste contains sometimes acidic waste, sometimes basic waste, and they are pollutants. So to prevent the damage that they cause to the water body and the flora and fauna related to that water body, these factory wastes are neutralized by adding suitable basic substances, and only then it is released out. So this is one use of neutralization. Now we have seen neutralization is a reaction between acid and base. So for example, if there is something called hydrochloric acid, which is written as HCl, why HCl? H for hydrogen, Cl for chlorine. Sodium hydroxide, sodium is Na, hydroxide is OH, hydrogen is H, hydroxide is OH. Now hydrochloric acid plus sodium hydroxide, acid plus base, when they combine together in suitable amounts, the acidic and basic nature is destroyed and salt and water is formed and energy is released. What happens? It gives sodium chloride. It gives sodium chloride. Sodium chloride. Cl and Na joins together from sodium chloride. And then we have one H here extra, one O and one H here extra. Those H plus H becomes H2O. What is H2O? H2O is water. H2O is water. So this 2 should be a subscript 2. Okay. Now water is H is written below on the right hand side of the H2 is written H2O, water. So that is why we said it produces salt and releases water and energy. Plants do not grow well when soil is either too acidic or too basic. So bases like quick lime, calcium oxide, or slaked lime, calcium hydroxide are added. Lime or limestone products are called calcium. Calcium oxide, calcium hydroxide, or acid. Oxide is acidic, hydroxide is basic. This is added to the soil. So the acidity or the basic characteristic of the soil is removed, and then plants can grow. Organic compost releases acids to the soil. Organic compost is what? Made from the manure. Okay. This is the way neutralization is used in agriculture. Now, demonstrate the effect of different indicators like litmus or turmeric on hydrochloric acid or sulfuric acid or nitric acid. Nitric acid is HNO3, sulfuric acid is H2SO4, acetic acid, sodium hydroxide is NaOH2. So, all these numbers you should write in the subscript, right? Calcium hydroxide, these various materials. Now, this one in red litmus solution, that is litmus paper, blue litmus solution, Phenolphthalein or methyl orange. So this hydrochloric acid, red litmus, there is no thing. Blue litmus, it turns red. It means what? Acid turns litmus to blue to red. Sulfuric acid turns acidic in litmus, it turns to red. Acids turns to red. Acids turns to red. Hydroxide base, it does not turn the blue litmus anything, but a red litmus, it turns to blue. Sodium hydroxide turns to blue. Calcium hydroxide turns to blue. Magnesium hydroxide turns to blue. This is the litmus reaction. Here, the acidic is colorless, but when a base is added, it turns pink. Again, when you add an acid, it becomes colorless. So, methyl orange. In methyl orange, it is pink. The acidic is pink. And then base, it is yellow. Acidic is pink, base is yellow. This is the reaction of certain materials. This, if you remember, it will help to answer some small questions. So in summary, acidic substances are substances which contain an acid, they are sour tasting and are soluble in water mostly and corrosive by nature. Basic substances are which contain a base, they are bitter tasting chemicals, may or may not be soluble in water. If soluble in water, they are called alkali and they are soapy to touch. Acid turns blue litmus red, bases turn red litmus blue. Acid turns blue litmus red, bases turn red litmus blue. Substances which are neither acidic nor basic are called neutral. Solution of the substances that show a different color in acidic, basic or neutral solution are called indicators. It can be liquid or it can be dried on a paper called litmus paper, etc. Indicators are substances that change color in the presence of acid or base. Organic acids are substances with acidic properties that occur naturally in plant, formic acid or lactic acid, naturally in plants and animals. An acid and a base neutralize each other to form a salt. Salt may be acidic or basic or neutral. Water molecules present in the salt crystal gives the salt its shape and characteristic or a look or a texture. Crystalline nature is because of the water molecules present in the salt crystals. This is called water of hydrolyzation. The water molecules present in the salt crystal which gives the crystal its shape is called water of crystallization. Hydrated salt means water containing salts, water contained in salt, hydrated salt lose their water of crystallization on heating. When you heat, the water becomes water vapor and change into powdery substance called anhydrous salt. So if you have water of crystallization, if they are hydrated, they will have a crystalline nature. If it is heated and water is lost, it becomes anhydrous salts. Now, some examples of acid, mineral acids are sulfuric acid and nitric acid because what nitrogen, sulfur are minerals that we obtain from nature. Organic acid are obtaining in plants and animals, citric acid in lemon or acetic acid. Alkalis are bases which sometimes get added to the water, diluted in water. Potassium hydroxide or sodium hydroxide are alkalis. What are weak bases? Copper hydroxide, ammonium hydroxide are weak bases. Strong bases are what? Potassium hydroxide and sodium hydroxide are strong bases. Because they are strong bases, they can mix with water and become diluted and become alkalis. Thanks for watching this video on acid, bases and salts, NCERT pattern, class 7, chapter 5.